Chemistry is the study of matter, its composition, and its properties. And matter is everywhere. You are made up of matter, you consume matter, the air around us is matter. And this year we're going to start by describing what matter is, and then later in the year we'll be talking about the chemical changes that matter undergoes. So regardless of the substance, there are 4 characteristics that all matter share. First off, all matter has a mass. That mass describes how much stuff is in the matter. If something weighs more, has a greater mass, it is made up of more stuff. We will also see that all matter takes up space. This space that it occupies is called its volume. And this may seem weird at first, but just because something weighs more doesn't mean it will occupy more space. How much space a given amount of mass takes up, that's called that substance's density, which is going to be one of the first topics we'll study this year. We're also going to see that all matter at its core are made up of tiny little particles. These individual particles can be made up of different things. The particles that make up matter could be atoms. The particles that make up the matter can be called molecules. The particles that make up the matter can be called ions. And what particles make up the matter go on to determine many of the properties of that matter. And we're going to study that in great detail this year. And lastly, we're going to see that every sample of matter that you investigate this year, the particles in that sample are in constant motion. Now, this motion doesn't have to be flowing motion. It can just be solid little particles vibrating in space, or it could be the rapid motion of the gas in the room right now. But it doesn't matter if you're talking about a solid steel beam or the air in the room. The particles that make up that substance are in constant motion. And basically anything we study this year that isn't matter is going to be energy. Matter and energy are very closely related to each other, and energy is often considered a property of matter. But really, it's going to be that matter's ability to do some action or work. For example, a candy bar is made up of a lot of matter, but the chemical energy that holds together the molecules in that candy bar can be used to fuel your body. That energy stored in there, that chemical potential energy, can be realized and made to do work in your body. And I want to make something clear. For all intents and purposes in this class, things that are matter will stay as matter, and things that are energy will stay as energy. Although we can convert matter into energy in a nuclear reaction, this year we're going to be studying chemical reactions, and chemical reactions do not involve converting matter into energy. In chemical reaction, all of the matter that was there prior to the reaction will be there after the reaction. We merely just have a rearrangement of the matter, a breaking and making of bonds, but never destroying matter. Matter in a chemical reaction will always be conserved, and this is a major law, the law of conservation of matter in chemical reactions, that'll be the basis for all we do this year. In this activity, we're going to look at 6 different substances that are all pure substances, but they're made up of different kinds of particles. What I want you to do is I want you to look at these 6 different boxes that are microscopic views of the particles in that matter, and I want you to try to answer the following questions. Can you identify the number of individual particles in each box? And then when we look at the nature of these particles, can the particles that make up a substance be an atom? Can the particles that make up the substance be a molecule? And then using the information provided in those boxes, try to come up with your own definition of what the difference between an atom and a molecule may be. Well, we can see that we have 7 particles, 6 particles, 17 particles, and 5 particles in the unlabeled boxes. In the first box, we're told that there's 9 particles, and I see that there's 9 squares. And it's labeled that 1 square is 1 atom. So if there's 9 particles in the box and 9 squares in the box, that's saying that yes, the particles that make up that substance are individual atoms. So yes, a particle can be a single atom. But in the next box, I see that there are 6 particles. And there are 6 things clustered in there that both have a square and a circle in them. And we can see that circled there, it's saying in the model that a square with a circle together is a molecule. And so yes, particles in this substance are molecules. So we can see sometimes the particles are atoms and sometimes the particles are molecules. Take a moment to see if you can label each of the boxes with either an A, meaning the particles are atoms, or an M, meaning the particles are molecules. After doing this, I think the key to figuring out the difference between an atom and a molecule comes down to this box right here, R2. We can see that the substance only has one shape in there, a circle, but that all of the particles have two of those circles touching each other. That touching represents a chemical bond, and that is the key of an atom versus a molecule. An atom is the smallest unit of matter that retains its own properties, but a molecule is when you have two or more atoms chemically bonded. And you may be saying to yourself, but wait, isn't it different if I have two of the same atoms bonded versus two different atoms bonded? And yes, it is, but not for this term here. Not for atom versus molecule. A molecule is any substance that has two atoms chemically bonded, and an atom is when you have a single unit of matter that retains its own distinct properties. The circles are distinct from the squares, and they're distinct from the triangles. And when you have only a circle or only a square or only a triangle by itself, that is an atom. But as soon as you bond two things together, whether two of the same or two different, you now have a molecule. So in the case of this substance SQR, it is one molecule made up of two different types of atoms, an SQ atom and an R atom. But when we look at the substance R2, it's still a molecule, but now it's made up of two R atoms, chemically bonded. Each of these letters, SQ, R, and T, represent different types of atoms that are present in these substances. Sometimes that is the only type of atom. Sometimes there are more than one type of atom chemically bonded to each other. Following this pattern, can you attempt to figure out what the name would be, the chemical formula would be for this substance here? And while it does not matter which sequence you put them in, you should have a T, an SQ, and R2. 2 next to the R to represent there are two round atoms, an SQ because there's a single square, and a T to represent a single triangle atom. This TSQR2 substance is a molecule composed up of three different types of atoms. Every substance on the previous page is a pure substance because pure substances are any type of matter composed of only one type of particle. It doesn't matter whether that particle has more than one atom in it. If every particle is identical, it is a pure substance. Look back at the previous boxes, you will see that every one of those 6 boxes, every particle is identical to every other particle in that sample. However, some of those substances are elements and some of those substances are compounds. Specifically, 3 of those substances are elements, while the other 3 are compounds. Can you go back and figure out which substances are elements and which substances are compounds? Try to figure it out, and I'll be right back to tell you the answer. Well, maybe you figured this out, but our 3 elements are SQ, R2, and T. And our 3 compounds are SQR, TR2, and TSQR2. I'd like you to try to use this information to come up with your own definition for an element versus a compound. I'll give you a hint. Focus on R2 being an element and not a compound. Well, an element is any substance that is a pure substance made up of only one type of atom. So SQ and T, obviously an element, but R2 is also an element, even though it's a molecule, because while it has a chemical bond, it is 2 of the same types of atoms chemically bonded to each other. Where compounds are going to be any substance that is made up of more than one type of atom chemically bonded. So when we're talking about pure substances, again, pure substances have to be any substance where every particle in the substance is identical. But those particles can be either elements or compounds. They are an element if they're made up of only one type of atom. They're a compound if they're made up of more than one type of atom. So again, an atom is the smallest unit of matter that has its own unique properties. A molecule is any particle that's made up of two or more atoms chemically bonded. These could be the same type of atoms or they could be different types of atoms. An element is any pure substance that is only made up of one kind of atom. Elements could be molecules as long as all of the atoms bonded are the same type of atom. In fact, we're going to see that there are 7 elements in nature, which we call the diatomic elements, because they exist in nature as diatomic molecules, 2 atoms of the same element bonded together. Memorizing these is important, so we've actually come up with a mnemonic you'll hear a lot called Hofbrinkel. Hofbrinkel stands for hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. These elements are diatomic elements, and you need to memorize them. And lastly, compounds are also pure substances, but they're made up of 2 or more kinds of atoms in their particles. So they're pure substances because they're only made up of one type of particle, but those particles are compounds because they contain more than one type of atom bonded to each other. There are only 118 known elements, but we have millions of compounds, and we're going to be studying many of them this year.